Hello, my name is Eric Grajak. I'm with Prime Photonics, and I am going to present a non-contact torque and torsional vibration measurement system. We are looking for transition opportunities for this technology. During the presentation, I ask that you think of how you might use the technology and come to talk to me after the presentation or send me an email to start a conversation. A few words about Prime Photonics. We were founded over 20 years ago, and we are located in Blacksburg, Virginia, right next to the Virginia Tech campus. We are best known for our blade vibration and blade tip clearance system, which is a successful commercialization of SBIR technology from about 8 to 10 years ago. We specialize in sensors for turbo machinery, especially optical sensors, and we have current research areas in inlet distortion, crack detection in turbo machinery blades, and the area that we are going to discuss today, torque and torsional vibration, which is the most advanced of the research areas and is ready to transition to a product stage and to commercialize the resultant work. The Navy has a need to sense the torque going through a shaft without contact, without shaft modifications, with nothing attached, even in the case of non-ferrous shafts. So we developed a product that is a non-invasive torque sensor. You can see the key performance parameters here, which we exceed with the current product, including a torque measurement accuracy of better than 2% of full scale. And the product currently works on a rig, and we are looking for opportunities to bring it to the field and to qualify it for flight testing. The expected transition target is the FA-18, and the technology is applicable to any drivetrain, including fixed wing, rotorcraft, but also shipboard. And it's also applicable to industrial drivetrains in power generation, mining, agricultural equipment. Our timeline for production is to start production in late 2022 or early 2023. The operational need stems from an increase in power going through the aircraft-mounted accessory drive or AMAD shaft on the FA-18 platform, and that increase in power has led to premature AMAD failure. The solution is to monitor the torque transmitted through the AMAD shaft through a non-contact torque sensor for non-ferrous shaft. The solution is the TVS instrument pictured on this slide. TVS stands for Torsional Vibration System. It is an all-optical sensor that measures the speed and angular movement of rotating shafts. It features two probes looking at the shaft. Those optical probes track the unique surface imperfections of the shaft and track that fingerprint, that unique fingerprint of the shaft in two places. Torque is calculated from the twist using shaft geometry, shear modulus, and sensor separation. And torsional vibration can be measured directly, either as a rapid change in speed using one probe, or a rapid change in twist using the difference between the two probes. The TVS instrument measures torque 16 times per revolutions, and it works over a range of 500 to 20,000 RPM. This real-time fully non-contact measurement instrument is completely EMI immune because it is an optical sensor. The technology is currently in phase 2 SBIR, with the milestones on this slide showing the progression of the TRL level. The testing that was to occur at Pax River has been delayed due to COVID, so the first 2 milestones are delayed. But we have successfully tested the instrument in-house on a test bench. How is our TVS instrument different from what's in the field? Well, torque and torsional vibration is typically measured by strain gauges attached to the shaft, or a torque meter, which is a modified shaft and instrumented in a package and needs complete disassembly to implement. By comparison, our TVS is ideal for retrofit. It's completely non-contact, there's no modification to the shaft, and it works with any shaft material. Our TVS system is also an ideal diagnostic tool. It's portable and it's reusable. It is also capable of providing permanent monitoring as a permanent installation, and it's very easy to install. We just need to have the probes looking at the shaft and start recording. TVS is also cost effective. It's a one-time cost. It is comparable in cost to a strain gauge installation, but a strain gauge installation requires a trained vibration consultant to install and use it. TVS does not. And a torque meter is extremely expensive. It is in the order of 2.5 to 4 times more costly, and it requires expert installation and precise alignment. The near-term objective for transition to the fleet is to use the TVS instrument for engineering applications on test rig and on an FA-18 flight test aircraft, with the potential for fleet implementation. We are interested in finding other platforms that have similar torque or torsional vibration measurement needs. The technology fits into any platform, airborne, ground, or naval. The DOE could also be interested for applicability to power generation machinery, particularly couplings. Commercial uses include turbo machinery for power generation, for oil and gas, for mining, or for agricultural equipment. We already have a variation of the sensor which does not meet all the Navy specifications because it uses labels applied to the shaft. That version is fully functional, and we have started selling a few of those products. Navy support would be helpful to find transition targets and to support marketing this version to the primes. The full version of the sensor is in phase 2, and we are looking for post-phase 2 funding to ruggedize the system for a DoD program of record. And we're looking for connections with other branches of the DoD or with the DOE to find other potential platforms. If you are interested in the TVS product, or if you can think of ways to use the technology to measure torque or torsional vibration, please come talk to us. You can get in touch in various fashions. At the end of this presentation, I will answer any questions in the meeting area next to the theater. You can meet us at the Navy STP booth, 537, tomorrow. And you can contact us. My contact information is on this slide, as well as the email for our technical director, Josh Soul. You can also use info@primephotonics.com as an alternate email address, or come see us on our website and browse all the technology we can offer. Thank you, and I look forward to meeting you and discussing your applications.